Welcome to Regression and Classification in Python. In this lesson, we will explore two key ideas in machine learning, regression and classification. You will see simple examples and build up to a small hands-on project. Do not worry if you are new. We will go step by step. Running the cell now. Before we dive in, try to think of situations where you would want to predict a number or put things into categories. If you like learning this way, please like this video, leave a comment, and subscribe for more coding lessons. What are regression and classification? Regression helps us predict numbers, like a house price or temperature. Classification helps us sort things into categories, like if an email is spam or not. We will start with the basics. Running the cell now. Think of more real-life situations where you use guessing numbers or picking categories. Let's start by creating some pretend data so we can practice predicting numbers. We will start regression with a kitten example. Here, we want to guess the weight from the age. This is a list of ages in months for our kittens. And here is a list of their weights in grams. Running the cell now. Can you think of other things where one number increases as another grows? Seeing a table makes patterns clear. We want to see how the ages and weights match up. We will go through each item to print them together. This helps us see the pattern between age and weight. Running the cell now. Try changing the numbers to see how the pattern changes. Regression sounds fancy, but sometimes it is just finding a simple rule. Let us make a tiny function to predict a kitten's weight from age. I notice that the kittens gain about 100 grams each month, so we use that pattern. This formula lets us try other ages. Now, we ask our function for the weight of a 6-month-old kitten. The result is the predicted weight. Running the cell now. Change the age in predict_weight to see what happens with other ages. Time for your hands-on prediction. Now it is your turn to try. You can type in any age. This asks you for an age in months. You will see the predicted weight right away. Running the cell now. Try a few ages. What happens with 0 months? With 12 months? If you enjoy these interactive examples, please like, comment, and share. Real models can be updated as you learn more. You can always adjust your rule if the pattern changes. Say kittens gain 120 grams per month now. This new rule is easy to change and try. Here we use the new rule to predict the weight of a 6-month-old kitten. Try both formulas to compare your results. Running the cell now. What if growth slows down as kittens get older? How would you change the formula? Quick recap on regression. Regression is about finding a rule to predict numbers. It is like finding the line, curve, or rule that connects dots. We used a simple example and wrote code to predict the next value. Let's try a new kind of problem, classification. Running the cell now. Pause and think, when do you need to predict a number instead of a category? Classification means putting things into groups or categories. Let's try a classic classification, apples versus oranges. Here is a list of fruit colors. And this is a list of the true labels for each color. Running the cell now. Think of other features you could use instead of color. Watch how a simple rule can work for basic classification. Let us make our own classifier. If the color is orange, we will say it is an orange. This is the key rule for our guess. If it is not orange, we will guess apple. Now, we test this rule on all the colors. We print each guess so we can check our logic. Running the cell now. Try changing the rule for green fruit. What could it be? Let's see your own fruit classification in action. Now you can try classifying a fruit yourself. Type in a color to see the result. You will see the guess printed below. Running the cell now. Test orange, red, green, and any unexpected color like blue. Let's test our rule's limits. What will our rule do for a color it does not know? Try typing a strange color here and see what happens. This will run the same classifier. It will still make a guess based on our current rule. Running the cell now. If our guess was wrong, how would you improve the function? Would you add more colors or rules? Sometimes you need your program to handle surprises. Now let us make the classifier safer. Unknown colors get special treatment. For orange, we say orange. For red or green, we guess apple. Anything else gets a result of unknown. This time, if we try blue, the function says unknown. Running the cell now. What other unknown types might you want to catch in real data? Built-in tools using scikit-learn. Python scikit-learn library has many tools for regression and classification. We will use one now to show how easy real-world machine learning can be. Running the cell now. You do not need to memorize everything. Just see what is possible and try small experiments. Sometimes using a library saves lots of time for real data tasks. Now we use a standard tool to do regression for us. We import linear regression from scikit-learn. NumPy helps format the data. We convert our ages list into a shape scikit-learn likes. Weights become a matching array. We make and train our regression model using the data. Now it learns the pattern for us. We use the trained model to predict a 7-month kitten's weight automatically. Running the cell now. Try changing input values or using your own data. Many real-world problems use libraries to make tasks simple. Now let us try classification with scikit-learn too. We bring in decision tree classifier. We need to convert colors into numbers for the model. Colors get mapped to numbers. Labels get turned into zeros and ones. We build our decision tree model and train it with the data. Now we predict a fruit with color orange. The prediction is a number, so we decode it back to a label. If the prediction is 1, it means orange. Otherwise, the model picks apple. Running the cell now. Test this with other colors or even add new fruits. It is time for a hands-on project. You will see both regression and classification in one example. Quick mini project, predict exam grades. Let's put it all together. We have student study hours and grades. We will predict a grade from hours, then classify pass-fail. Running the cell now. Think about how you could collect your own data for a mini project like this. Good data is the first step in most projects. We are starting with hours spent studying and the grade scored. This list says how many hours students studied. This list shows their grades out of 100. Running the cell now. Is there a pattern in these numbers? Try plotting them later. Let us predict your score based on your study time. We use regression to guess what grade comes from hours of study. We already brought in linear regression and NumPy. We turn the hours list into a shape for scikit-learn. The grades become our known answers. We make and train our linear model. Now it learns the pattern. You get to type in how many hours you studied. The model gives its prediction for your grade. We round the result for clarity. Running the cell now. Try entering different hours to see how the prediction changes. How does the model guess for 12 hours or 1 hour? Classification often follows a prediction when we need to sort results into groups. Now we classify your predicted grade. If your grade is 60 or more, you pass. Otherwise, it means you did not pass. Printing the result shows if you passed or failed. Running the cell now. Raise or lower the cutoff line to change what counts as a pass. Debugging is a key part of every programmer's day. Common errors and safety tips. Double-check matching lists. Your features and labels should be the same length. Make sure to check for unknown cases in classifiers. Watch out for typos and missing parentheses. It is okay to see errors. They help you learn. Running the cell now. If you see a strange error, make a guess about what it means before asking for help. Small issues like this are common and easy to fix. Here is what happens when lists are not the same length. Only 3 ages, but only 2 weights. A loop will cause an error because one list is shorter. We show what goes wrong in the for loop. This block catches the error and prints a message. If you see index error, check your list sizes. Running the cell now. Practice, make your lists match and see the error disappear. Tips and tricks. Use functions to keep code tidy. Try scikit-learn for bigger problems. Print out steps to see what is happening. Test with surprises to see how safe your code is. Running the cell now. Challenge, make your own example prediction or classification. Show a friend and explain what your code is doing. Put your new skills to the test on something fun. Challenge exercise. See if you can. Make a predictor for your own data, like daily steps or pets' ages. Write a classifier for favorite foods or school subjects. Try first with simple rules, then use scikit-learn. Running the cell now. Post your own examples in the comments. I love to see your ideas. Great job making it to the end of this lesson. Recap, what have we learned? Regression equals predicting numbers. Classification equals sorting things into groups. Code can use rules you make or learn from data. Practice makes perfect, so keep going. Running the cell now. What would you like to learn next? Leave a comment with your suggestion. You made it. Celebrate your progress. Remember, like, comment, and subscribe to support this channel. Thank you for watching. If you found this lesson helpful, like the video. Comment with your favorite example. Subscribe for more. Share it with your friends. See you next time. Running the cell now. Try reviewing this lesson or sharing it with someone you want to help learn Python.